Hi, I'm Ernest Rutherford and I'm a physicist at the University of Manchester studying the structure of atoms. Currently, I'm conducting research and leading the Geiger-Marsden or gold foil experiment. I'm leading a group of researchers in this discovery, including Hans Geiger and Ernest Marsden. We are investigating how alpha particles interact with the thin sheets of gold. In our experiment, we are trying to find how J.J. Thomson's plum pudding model is used to determine how the positive charge is arranged inside the atom. We are firing the alpha particles at extremely thin gold foil to observe how the particles scatter. We expect that nearly every particle will pass straight through, and we're trying to find experimental evidence on this to better understand the internal structure of the atoms. However, to our surprise, a very small number of the alpha particles actually bounce back, and they all went directly backwards. I later compared this to finding a large artillery shell at a piece of tissue paper and having it bounce back at you. When we were performing this experiment, we chose gold because it can be hammered into thin sheets that are only a few atoms thick, making this the best material to use because of how thin it could be in the experiment. This project is occurring at the University of Manchester in Manchester, England, as that is where I am currently studying. This research is being conducted in 1909 and is in the physics laboratory. We are carefully analyzing our results before publishing our conclusions. During the time of this research, the major events happening in the world are Europe is experiencing a rapid industrial and technological growth. Along with this, Albert Einstein is developing the theory of relativity, and airplanes are becoming more practical, and the flights, because of how the Wright brothers are flying in their test flights. Scientists are making exciting discoveries about the radioactivity and the atomic structure. In this experiment, there were 3 other scientists that were directly involved. The scientists were Hans Geiger, Ernest Marsden, and J.J. Thomson. Hans Geiger is working closely with me to design and operate the equipment while detecting alpha particles and collecting experimental data. Ernest Marsden is a young student researcher and helps perform the experiment by directing alpha particles towards gold foil and recording how they scatter. He is watching the experiment and helping me make important observations and decisions about what to do next in the research. And then J.J. Thomson is not directly working with us, but he is the one that developed the plum pudding model, and that is what we are working on testing. So we're using his ideas from that to then test our theories and see how accurate his plum pudding model is. My role in this project is to lead the research team and develop research questions that will help the experiment. I work on supervising Hans Geiger and Ernest Marsden while they are analyzing data, and I also analyze their data too. My analysis suggests that the atom contains a very small, dense, and positively charged center. Because of these results, I am developing a new model of the atom and preparing to publish my findings in the next couple of years. The impact that this experiment has had on the physics community is it has changed the way scientists understand the atom. Our observations show that the atoms are mostly empty space with very small, dense, positively charged nucleus at the center. These results challenge J.J. Thomson's plum pudding model, and because of that, I'm proposing a new nuclear model of the atom. I believe this discovery will help future scientists understand the atomic structure, radioactivity, and the nature of matter that is needed to continue to develop new scientific ideas. The thing that surprised me most about this experiment was seeing a few alpha particles bounce back after striking the gold. I expected nearly all of them to pass straight through, so these results were completely unexpected. This led me to conclude that the atoms contain a tiny, dense nucleus where most of the mass and positive charge are concentrated. I even compared it to firing a large artery shell at a piece of tissue paper and having it bounce back, because this is how unbelievable the results seemed. This experiment really shocked me in the movement of some of the atoms and has made me want to continue more research in the future.